last class, so we discussed about the set of formulas, right? So we discussed a formula related to a rectangle, right? So with respect to centroidal axis, right? Your I-axis is bx cubed by 12, and I-y is hb cubed by 12, right? Similarly, we discussed for right angle triangle and isosceles triangle. Similarly, circle and semicircle, right? So these are the sets of formulas. Now we will use these formulas to identify the centroid for a composite type of problem. Whenever you get a composite section, so let us identify, right, based on a tabulation method. So here you can able to see that the question, actually in the question, they have not mentioned anything about the figure, right? The figure is not given. So only thing is we have to identify, we have to draw the diagram based on the question, right? So they mentioned that you have a moment of inertia of a T section. So it means a section is a T with flange of 150 into 50 and web of 150 into 50, right? They're asking you to identify moment of inertia with respect to xx and yy through the centroid of the section. So this is the question, right? So whenever they say a flange, it means that this part is a flange. So a part which is extended. So that one we call it as a flange. This is flange. Okay. Similarly, so this one, right, which is having lesser thickness, that one we call it as web. Right. So this one we call it as web. Okay. So whenever they say a flange, right, so which means this part, web is this part, right? So don't consider that always the first one will be your x dimension, second one is always a y dimension, right? It is not applicable here, right? So whichever is maximum, you have to consider as, accordingly, right? So in our case, you can able to see that flange as 150. So which means this is the higher dimension. So this B is 150, right? And T is 50. T is 50, right? According to this particular diagram, right? So similarly, web is 150, which means this distance. So the distance from here to here is 150, which means your A will be 200. A is 200. Okay. So 150 plus 50, right? 200. So, but only this web alone is 150, and this dimension is 50, right? So they will also give it as a high section, same category. So I section with flange 150 into 50 and web as 150 into 50. In that case, what you'll get, you will be drawing a section here, I section like this. So we'll be having something like this. Okay. So, but anyway, so this for your just for information, I'm telling you. So for even for I section, you can consider something like this, right? So if they give in wordings, you have to identify the figure. Go to draw this figure. Afterwards, you have to proceed with the usual procedure, right? Okay, so now I got this too. What I can do is, first thing is I have to split this into two simple pictures, right? Simple images. So this is my first one, and this is my second one, right? So this is one, this is two, right? And I'm going to fix this in your quadrant. So first quadrant, everything should be in first quadrant, which means your axis is like this, right? So your axis is like this. There's an x-axis, there's my y-axis. And if I am fixing my two rectangles like this, right? You know the dimensions. So this is 150, this is 50, this is 50, and this is also 150, right? Now the procedure is same. The first step is, since they mentioned you have to identify moment of inertia with respect to centroid, my first step is I have to identify the centroid, right? So our usual method, whatever we discussed to identify the centroid, we have to follow that. Okay. So I made a tabulation here. to identify the center. Let us do it one by one. So the first table will be section, second will be your area, third is x bar, fourth is y bar, then we'll call this as a into x bar and a into y bar, right? So the first section is my axis. In this axis, my first section is something like here. So it is somewhere here, something like this, right? So you know what are the dimensions. So your breadth is 50, height is 150. So I will write it here. B is equal to 50 and H or D, whatever this, it is equal to 150, right? And it is also having an offset distance. You can able to see that there is an offset distance here, right? So what is the offset distance? So 150 minus 50, it will be 100. So it is divided into 2, right? So it will be 50. This will be 50, right? Okay, before proceeding to this, I can reduce my work, right? I can reduce my work accordingly. So wherever I have whichever I can able to skip, I will try the maximum to skip that. Okay. So I already discussed that whenever you have an object which is symmetrical, so which means if I make your y-axis here at the center, you can able to see that it's like a mirror image. So whenever you have a symmetrical, your with respect to y means your x bar will be half of the total distance. If you have a symmetrical with respect to x-axis, then your y bar will be half of the total distance, right? So in this case, I can able to see that it is symmetrical about y-axis, which means my x bar will be total distance. Total distance is 150. So 150 by 2. So my capital X bar will be 75. I can directly identify. Okay. In that case, I can eliminate these columns. So I don't want to use this one, and I don't want to use this one, right? Because I directly identified what is my capital X bar, right? Which will reduce my work. Okay, so most of the time they will give a problem which is symmetrical. So when you have a symmetrical section, you can skip that part. So whatever which is related to that, we can skip that. Because I will identify capital X bar as sigma A X bar divided by sigma A. Right? So I don't want X bar and A X bar. Right? So there is no way. But this sigma A, I can use it for Y, right? So that's why I am keeping this. Okay? Right. So I skip this too. Now let us proceed. What is my area? Area is base into height. So it is 50 into 150. What is the value?
7,500.
So you are getting 7,500. Next, y bar. Y bar is h by 2, which is 150 by 2. Right? In that case, I will get 75. A into y bar, multiply and tell me. So your A into y bar. So A is 7500 into y bar is 75. 562500. Right? So this is my first value. Right? This section, my object is at the top. So you can able to see that it is having an offset distance in y. Your offset distance is 150. Right? And you identify what is your D. D is 150. H is 50. Right? I can write it out. So I can write that D is equal to 150 and H is equal to 50. Right? So B into H, same. There won't be any difference. So 50 into 150. So I will write down what is the value, which is 7500. Right? Y bar. So y bar is 150 is the your offset distance plus 50 by 2, 175. So multiply this two. So identify what is your 7500 into 175. What is the value for A into Y bar? 13,125,000. Yeah, good. Now we will identify sigma A. Right? What is sigma A? Sigma A is addition of these two. So I get 15,000. So similarly, sigma A into Y bar. Right? What is sigma A into Y bar?
1875000.
1875000. Right? So now I will identify what is my capital Y bar. Capital Y bar is sigma A into small y bar divided by sigma A, which is 1875000 divided by 15,000. So what is your Y bar? 125. Right? 125 MI. Yes. Now we identify both the values. Capital X bar, which is equal to 75, and capital Y bar is equal to 125. Right? So make sure this is capital X bar and capital Y bar, which means overall centroid for your object. Right? Small X bar indicates for a particular section what you consider. Okay? Right. Now we proceed with your moment of inertia. So for moment of inertia, I am going to make a new table indicating the same thing. So first I am going to indicate what is the section, whatever which is put considering here. Next, IXC, moment of inertia with respect to centroidal x-axis, moment of inertia with respect to centroidal y-axis, then IXX, right, and IYY. Right, this IXX and IYY. This IXX and IYY is changing with respect to the points. With respect to the points, right? For example, let me consider this particular figure. My overall centroidal location is somewhere here, right? 125. Right, this is my overall centroidal location. Right, I will mark it in a bigger way. So something like this. Right, but if I consider the centroid for this particular object one alone is somewhere here at 75. Two alone, right? Two alone is somewhere here. Okay. So whenever I want to add my moment of inertia, it has to be in the same origin. So இது மட்டும் தனியா இருக்கு, இது மட்டும் நான் ஆட் பண்ண முடியாது. இது எல்லாமே அந்த பாயிண்ட்டுக்கு ரிலேட்டடான மொமெண்ட் ஆஃப் இனர்ஷியா தான் you can add it, right? So my first thing is I have a point here, but my overall centroid is here. So I'm going to shift from here to here, right? So for that only I'm using parallel axis theorem. Right, I will use parallel axis theorem to shift my moment of inertia. Let me call my x bar, small x bar, as local centroid. From local centroid to global centroid. Global is capital, right? So to shift my moment of inertia from local centroid to location to global centroid location. Similarly for the next shape also, right? So for this, what we are going to do is we are going to apply this parallel axis theorem. Right? So in that case, this IXX formula is equal to IXC, moment of inertia with respect to centroid, plus area, whatever the area we are going to consider, into, right? So if you consider XX, you will get Y here. So because your distance, your parallel axis theorem, your distance will be perpendicular to it, right? So capital Y bar minus small y bar the whole square. This is the formula, common formula. Similarly, IYY is equal to IYC plus area into capital X bar minus small x bar the whole square. This is the formula for your second part. Okay. So these are the terms which you have to consider. These are the terms which you have to consider. Right? Actually, if I consider, I can combine all this as a single table, right? What you can do, you can take a landscape page and you can draw it. You can draw all the columns and you can complete it. So now we'll proceed with this, right? So we know what is your BH, everything. Let us apply in the formula. This is BH cubed by 12. This is HB cubed by 12, right? Similarly, when you come here, this is also BH cubed by 12. This is HB cubed by 12, right? Easiest way to solve these three problems quickly is creating a formula in a calculator, right? So think about it, all are rectangle. So in that case, your formula is similar. So one formula is enough to solve all these things, right? To solve all these things. Okay. So let me take some time. Let me take some time to explain it again, how to do these things. Okay. Yeah. So now I'm going to create formula for this IXX, so IXC and IYC. For this, I'm going to create a formula, right? So what you'll do, you have to press alpha first. So you have alpha here, press this alpha. I think, so press this alpha. So first alpha, right? After pressing alpha, you go to B. So BD cubed by 12. Let me consider the formula as BD cubed by 12. So I'm going to use two terms, B and D, right? Alpha plus B, right? Click this B. B is, you can able to see you having this dot icon, right? So that one, so this one, right? Alpha B, right? Then into, right? Then into what I do? So alpha again. Now this D. So D is nothing but sign here, right? Sign, right? So at the top you can able to see a D, right? So sign. Okay. So then you have to put shift. You have to press shift, then X square button. So this one, right? So because you have X cube at the top, right? In yellow color, right? You have to press it accordingly, right? So now what I have to put divide symbol, put 12, right? So you will get a formula like this. So your formula will be like B into D cube divided by 12. Your formula will be denoting like this. Are you getting something like this?
Yes, sir.
Yes, sir.
Yeah. Okay. Now, what I'm going to do is I'm going to change my B and D accordingly. For IXC, my B is 50 and my D is 150, right? Press calc button, press calc button. When I press calc button, it will ask you what is your B data. Enter as 50. Press equal to, now it will ask you what is your D data. Enter 150. Then you press equal to, you will get the answer. What is your answer you are getting? Yeah, you will get lots of values because moment of inertia is very, very large. You press ENG button, to get in 10 power.
14.06 into 10 power 6.
You are getting 14.06 into 10 power 6. Right now, you press again calc button. It will ask you again what is the value of B. Right now, your value of B is 150 and value of D is 50. Right, value of B is 150, value of D is 50. So what you are getting?
1.56 into 10 power 6.
1.56 into 10 power 6. Make sure this is HB cube by 12 formula. There is no change. B dq by 2 அதுதான் இது பதில் இது இந்த value whatever you get substitute is h value now. H value is 150 and B value is 50. So you will get the same whatever data here. So you'll get again same 1.56 into 10 power 6. Similarly, this one will be this value, right? 14.06 into 10 power 6. Now, the next step is I'm going to type this formula. Right? I'm going to type this formula. And again, I'm going to apply it accordingly. Right? So, okay. So again, I'm going to consider the same calculator below. Right? So now my formula, what I'm going to type is IXC plus area into capital Y bar minus small y bar the whole square. This is the formula I'm going to type. This formula suits for both I, Y, C also. It doesn't matter, right? So I need some values accordingly, right? Let me consider IC as B because you will get confusion in this A. Already இங்க ஒரு A இருக்கு, அதனால இதை நான் Aனே கொடுக்கிறேன். Right? These are the variables I'm going to choose. And this one I will call this as variable C, and this one I will call it as variable D. Right? So the procedure is same. Click alpha, then B. So this button B, then plus. So click plus button. After B, plus button. Then A. So again alpha. So plus alpha and A. So A is minus the symbol A, right? Then into button, right? This into button. Open a bracket. So open a bracket. Okay. Next alpha, right? Alpha. Then height button. So alpha C. Right, alpha C. This is make sure. So this is your bracket. Okay. So alpha C minus again alpha. Then your D. So D is fine. Right. Now you close your bracket. Close your bracket, then press x square. Right? You will get this entire formula. So your formula will look like this. So B plus A into bracket C minus D square. You will get something like this. Are you getting it like this?
Yes, sir.
Yeah. Now I'm going to use it in my location here. So I will call this in B plus A into C minus D the whole square. This is for my reference. Okay. Now for this first value, whatever I'm going to get here, my B is this one, right? IXC, right? So this is nothing but 14.06 into 10 power 6. Right? Again, you press calc and type this as a formula. For typing this, you don't go for into 10 power 6. You type it as 14.06. You have a button here, which is EXP. Right? This EXP button. So EXP 6. So when you do that, it will consider as 10 power 6. Okay. So next area. So area, what I'm going to consider is area here is a 7500. Area is 7500. Right. Next C. C is nothing but your capital Y bar, which is 125, right? And D is your small Y bar, right? D is your small Y bar. So D is your small Y bar, which is, what is your small Y bar for this particular case? 75. Any doubt on this?
No, sir.
Yeah. So this will reduce your work. Right? That's why I'm repeating this. It takes just a fraction of seconds to solve this, all these points. So just value மட்டும் கரெக்டாக சப்ஸ்டிட் பண்ணிக்கிட்டே இருக்கணும். ரைட், ஐஎக்ஸ் என்ன இங்கே எடுத்து இந்த வேல்யூ போடணும், ஏரியா என்ன அந்த வேல்யூ போடணும். ஸோ இந்த மாதிரி வேல்யூ போட்டுக்கிட்டே இருந்தால் டேரெக்டாக ஆன்சர் வந்துடும். ஆன்சர் டேரெக்டாக எழுதிக்கலாம். இல்லைன்னா ஒவ்வொரு தடவையும் இதை டைப் அடிச்சு உங்களுக்கு ரிசல்ட் பார்க்கணும். ரைட், ஸோ தட்ஸ் தி மெயின் பெனிஃபிட் ஆஃப் திஸ். ஸோ can you try this for all these 4 values? So now you tell me what will be the values with respect to all these things, right? You type it in the chat box. So you first you type for section 1, then section 2. So when going for section 1 and section 2, capital Y bar doesn't changes, so it will be same. ஸோ அப்போ வந்து பார்த்தீங்கன்னா உங்க பி வேல்யூ வந்து அப்படியே இருக்கும். ஒரு தடவை என்ட்ரி பண்ணிட்டீங்கன்னா பி வேல்யூ மாற்ற வேணாம். ரைட், இந்த ரெண்டு இதுக்கும் ஃபர்ஸ்ட் ஒன் இஸ் 32.81 into 10 power 6. Okay. Yeah, second section for this section. For the second one, your IXC will be this 1.56 E6. You can type it like that. Area is 7500. Capital Y bar 125, there is no change. Small Y bar is 175. 20.31 into 10 power 6. Okay, now we go for IYC. Same formula, there is no difference. So the calculator என்ன டைப் பண்ணணும் அதே தான். இப்போ சப்ஸ்டிட் பண்ணும்போது இதை சப்ஸ்டிட் பண்ணுவோம், அவ்வளவுதான். So substitute this as 1.56 into 10 power 6. Your area is again 7500, no change. Capital X bar, so you change it to 75. Change your B to 75. Sorry, C, you see, right? Change your C to 75. And small X bar is, for this, we are not identified. Okay, usually it will be 75, right? So if you identify, either 50 plus 50 by 2. So this is 75, right? Similarly, this also will be 75. Okay. So small X bar is 75. Which means I think this gets cancelled. Right? I think capital X bar and small X bar is same. It gets cancelled. So which means IYC is just direct value. So I think it will be 1.56 into 10 power 6. And this will also be 14.06 into 10 power 6. I think this will be your answer. Now what you do, you just add it. That's it. So add all your IXX and IYY. So add this to, yeah, 53.12 into 10 power 6. This is my IXX, right? So IYY, your IYY is just add this to, so 15.62 into 10 power 6. Right? This is my IYY. Right? So this is nothing but your centroidal location. This is the moment of inertia with respect to the entire centroidal section. Right? This is my answer.